Okay, now we're going to be looking at solving linear systems of two equations with two variables. So your system should look like this. You have equation number 1, equation number 2. In equation number 1, you have a constant multiplied by x plus a constant, another constant multiplied by y. All of that is equal a constant number. And you have the same thing at the bottom. Gotta be careful though, because this is a linear system because all of their exponents must be 1, the exponents of the variable. So that x is to the power of 1, that y is to the power of 1, that x is to the power of 1. But usually we do not write them down because this is exactly the same as not writing down the exponent 1. And you cannot have variables at the denominator because it will change the exponent. The exponent would be -1 when we bring down the x at the denominator. And here's an example of a system of linear equations with two variables. You got x as your first variable, y as your second variable. So you have 5x minus 3y is equal to -7. -4x plus 2y is equal to 6. And why is it called linear equations? It's because we can rewrite them as an equation of a line. Each one of them can be rewritten as the equation of a line. So let me get the first equation. So I'll just rewrite the second equation, -4x plus 2y is equal to 6. So I just rewrite the second one. And now I will isolate the y variable. So I will bring that -4x to the other side. I'll have 2y is equal to 4x plus 6. And then I will divide by 2 both sides. So I'll have y is equal to 2x plus 3. And now you can notice that we have the usual form for the equation of a line, where 2 here is the slope, so you have the slope of your line, and 3 is your intercept. So you get your slope and your intercept out of that. I could do exactly something similar to get the slope and intercept of the first equation. And now we're going to be looking into the solutions of this kind of systems. Okay, so now for the solutions of a system of equations. So a solution of a system of two equations and two unknowns is a pair of values. So you have a value for x, you'll have a value for y, that are assigned to the variables and which simultaneously satisfy the two equations. So you have to satisfy equation number 1, and you also have to satisfy equation number 2. And we're going to check that my solution here actually satisfies both equations. So I'll just rewrite my 3 here. I'll multiply that by my value of x, so multiplied by 2, plus the value of y, which is -1. That must be equal to 5. And it is equal to 5 because this will give you 6 plus -1 is going to be 5. So it works in the first equation. And let's just check the second one. It's going to be 4 multiplied by 2 plus 9 multiplied by -1. And this should be -1 as the final answer, which it is because this is going to be 8 plus -9, which is -1. So equation number 2 is also satisfied. So that means that x is equal to 2 and y is equal to -1 is the solution of this system of equations. And we can rewrite that as 2, -1 like this as a x and y coordinate. So now we're going to check the number of solutions possible into that kind of system. Okay, so now we're going to be looking at the number of solutions of a system of two equations and two variable x and y. So there can be a unique solution, no solution, or an infinity of solutions. So that's the three possible outcomes. First one, well, when you have a unique solution, both of them are a line. So what does that mean? It means that your equation number 2 is going to look something like this, maybe. And your equation number 1 is going to cross your equation number 2 at a single point with x and y coordinates. And these x and y coordinates are going to be the solution of your system of two equations. So the only place on the x and y plane that satisfies equation number 1 and equation number 2 is going to be here, where the two lines crosses. The no solution situation is when your equation number 2 looks like this and your equation number 1 is a parallel line, so it never crosses the equation number 2, so you have no solution. The infinity of solutions situation is when your equation number 2 is like this, and I'm going to make it a little bit wider, and your equation number 1 is going to actually be exactly the same line as equation number 2. So each of them, both of them are going to be the same line. So all the points on that line is going to be a solution. So that's why there's an infinity of solutions. So that's it for this video. See you in the next one.